I hope you clap like that after the talk. I'm also very glad that we had a lunch break, because following some of the stuff these guys had in the morning was, that'd be a tough task. And so let's thank them for all the hard work that they do to allow us to build really great tools on top of what they produce. So my name is Joe Conway. I am the CEO of StableKernel, and we are a mobile development consultancy. And we have to write backends an awful lot of the time. And we started using Dart to build our server-side stuff about a year ago. And as a programmer, the most important thing is I don't want to write a lot of code, because I'm human and I make mistakes. And the more code I write, the more opportunity for mistakes. So as we were building things, we were abstracting it into another layer, a lower layer, that we call Aqueduct, or Aqueduct. I actually do not know how to pronounce it. And just to clarify, so what I mean when I say it's an open source server-side framework, right? Written in Dart. And to clarify what I mean by that, just in case there's any confusion, you got to get up where you got some clients, and they're talking over HTTP, probably with JSON or some sort of format like that, and they're hitting an API, and then maybe that talks to a database or another larger system, and that's where Aqueduct goes, right? So pretty normal stuff, right? One of the things we wanted to do is, because we have to start from scratch on all the projects that we work for, is we wanted to be able to get moving very, very quickly. And so the setup process is extremely quick, and there's templates to get started. And all you have to do is you set up your packet or your pub to activate Aqueduct globally. You run the setup one time. I'll leave that surprise for what happens when you actually run it yourself. You create a new project, and then you're ready to go, right? And the things that come in the template here, it's kind of a fully featured web application, right? It's kind of ready to start and get you going, and you can build on top of it. And so this magically just fit on this slide. But you get authentication, right? So there's an OAuth 2 implementation that's available. You get a few routes hooked up to ensure that you can do authentication. You get a registration endpoint. You get scripts for running your application on EC2 and on Heroku. You get the ability to reflect in your code with a one-liner and generate an open API specification of the API that you've built, right? You get a test harness, you get stuff for testing, you get a configuration file so you can put it onto Travis, right? Just kind of giving you all the things so that you just say, okay, I'm gonna write some code, right? So, if you're gonna write that code, you need to understand how it works. And it's pretty simple, right? There's nothing really revolutionary about this. A lot of frameworks that do the same thing. You have this concept of request controllers, and they form a stream. And when a HTTP request comes into the system, it starts at something called a request sink. And that request sink forwards it on to a router, and that router forwards it on to, based on the path, different HTTP controllers or different types of things that are going to handle that request. And along the way, something might respond to the request, or it might forward it on to a subsequent controller to handle that request. So for example, once the request gets to a router, and there's no registered route for the path of the HTTP request, it'll respond with the 404. If it matches one, it passes it on to the next guy, and that one's responsible for responding to it. Make sense? Pretty standard stuff. And so that request sink, that thing that's sort of the initial part of the chain, when you create an Aqueduct application, you subclass request sink, and this is where you set up your application. This is where you're going to set up your routing. You're going to set up any resources that you're going to use, like a database connection. And the routing is, again, pretty simple stuff, right? This is an example of a route specification. And you're probably familiar with syntax like this, or this specific one, where I'm saying, hey, this route will go to /articles, and then I got these brackets here, which means optional. So /articles/some index. The colon here means a variable, a path variable. So this particular route says if you send a request that has /articles or /articles/whatever, then we're going to move on to something called an article controller. That'll be the thing that's responsible for responding to the request. The typical situation used, there's a lot of different ways to actually handle a request. The middle ground is an HTTP controller, so it's got a lot of power, but still retains some flexibility. There's things that go in both directions. Like I can use a closure here, right, in this spot, and I can just have that respond to it. But HTTP controller is one of those things that gives us a lot of value and allows us to properly compartmentalize our code. So when you get into an HTTP controller, you've already been matched on the route that you care about. So we're coming into here, we have /articles or /articles/something. And what an HTTP controller does is it picks out a method that we call, it's a Dart method we call a responder method. And responder methods are always decorated with an HTTP method, right? So this is a GET. So if I get into this controller with the request, and it's a GET request, this method's going to be invoked. The responsibility of a method like this is, number one, it has to be asynchronous because you're probably going to do some stuff in it. And then it has to return a response object. And there's constructors for all the different responses that you need. Response objects know how to serialize and encode data. So this will take these articles that we get from somewhere, and it will serialize this and encode it into JSON by default. Now, you can add different encoders, you can add different decoders, but this is the basic format of an HTTP controller. I mark it up, it calls the method, responds to a request. Of course, in this particular endpoint, we could get /articles/articles/index. And so if we wanted to run a different method for the particular case when the endpoint is /articles/index, we add it as a parameter to a different HTTP GET responder method. And so we're basically saying here, in the route, we've called this thing index. We called this a path variable in index. And we specify the type, and we're going to get whatever that path variable is parsed into this particular type. So the two different endpoints for that particular route are going to call one of these two methods, right? And this particular method would go get a specific article and return a different response. So the great part about this is, let's say, for example, you passed in something that could not be parsed into an integer. It would select this method, try and parse that path variable into an integer, fail, come back and return you a 404, and will not call your method. Now, obviously, once you're handling a request, you can always access the Dart standard library request object. So here's some code that you might write to go in and grab query parameters from the URI, to grab headers. We want to make sure that they actually include this particular header, and so if they don't, we return a bad request. But that's boilerplate, and the idea is to write less code because more code means more errors. And so HTTPController also has a built-in ability to handle that type of thing. So I can say, listen, this particular method, it's going to have a header with X required ID, and it's going to have a query parameter, potentially contains. And for you Dart programmers, everyone here, you know that the squigglies here, that means optional. And so that actually means the same thing for this particular request handler. I can get this method invoked when I send an HTTP request, and it could potentially have a contains query parameter. If it doesn't, I get null for the contains variable. And if I do, I get whatever value they passed. But this header here, this is in the positional arguments, which means that it is required. And so if you get to the point where this method has been selected, and you did not attach X required ID, you're going to get a 400. It's going to say that, hey, by the way, you're missing X required ID as a parameter, as a header. So again, it's just making the things that we have to do over and over again a lot more simple. Now, because the way this thing is structured, this idea of having request controllers that either pass it on or return some response and do not pass it on, we can add middleware into the whole thing. And so one of the examples that comes built in is an OAuth 2 implementation. And within the OAuth 2 implementation, there's a request controller called authorizer. And we can just put that in between the router and a particular controller. And that thing's responsible for looking at the authorization header and saying, you don't match, or you do match, and I'll let you go a little bit further. If you fail, you get a 401. You do not go any further. And that works together with an object called an authentication server, which implements OAuth 2, and then you provide the persistence for what the auth server wants. So it'll say, hey, I want you to store a token. You store it in Postgres or whatever database you're working with. So the way that these routes are set up, this concept of just sort of chaining things together, we want that metaphor to make sense in the way that you actually write the code. So you look at other frameworks, some of those controllers, those things that handle things, they kind of have to know where they are in that. They have to explicitly say, like, hey, now you can go on to the next one. That type of behavior is sort of handled at a higher level. You're just returning requests and response objects. If you want to go forward, return a request. If you want to complete the request and respond to it, you return a response. And this is the thing that forms that stream. So we set up a router. We can pipe it to an authorizer. That's that thing that checks for authentication. And then we can generate a new controller. Now, there's a little subtle difference here between pipe and generate. The idea is this. When you have an HTTP controller, when a request comes in, it has properties that represent things in that particular request, right? It has an actual reference to the request that's coming in. If it decodes a HTTP body, it's going to have that body as a property. And so when you're working in an asynchronous environment, this particular controller could get halfway through processing a request, and then a new request could come in, and it would trump those properties. And that would be bad. So generate means for every request, create a new instance of this guy. Pipe, because you don't have to, it's just a pass-through, right? The authorizer does not keep any state about the request it's processing. So pipe versus generate. Small little nuance. The different strategies for these authorizers. So if you're familiar with OAuth 2 specification, you have resource owner, you have code, authorization code, you have client. The default is resource owner because most URLs will have that. The ability to change the strategy to something like the application level client ID, client secret pair is done right here. And so the idea is you can come into one place and kind of see the entire structure and flow of your application, but all that code is actually compartmentalized and allows for a better structure of your application. The really great part about this, though, is because of this structure, you can actually spawn that entire stream onto multiple isolates. And so this allows for a lot of great things, right? So you don't have to do anything special. You just set up your request sync and you say, here are my routes and here are my resources. And there's this thing called an application that sort of manages and supervises all of these different isolates. And it's responsible more or less for being able to round robin deliver requests into each one of these isolates. So you get multi-threading, right? And each set, or each isolate and its request sync will have its own set of resources, like a database connection. You don't necessarily have to do it that way, but if you think about a typical application, you probably have a pool of database connections, and as you're doing things sort of concurrently, you go and ask that pool, like, hey, let me use your database connection for a second. I've made my request, now I'm done, here's the connections so someone else can use it. With this process, you don't have to think about that because each one of these guys has their own set of resources. And because of the way that isolates work, you can't really get in a situation where you create race conditions between the two. And opting into that behavior, you just specify when you start the application, right? So you have that request sync, that's the type parameter for an application. When you start the application, you just say, I want 3 of those things. The other great part about that is it kind of forces you into this model of writing a stateless web server. And so you already know that once you've done it once on one machine, it's technically kind of distributed across a number of threads in that one machine. So when you scale it out to multiple machines, you put it behind a load balancer, that stuff's just going to work. You've already kind of tested that behavior. So that's the request handling stuff. There isn't really anything other than the isolate stuff, which is pretty neat. That should be pretty typical stuff. Having an ORM is another portion of this. There's really 3 major portions that I'll touch on today and a few accoutrements at the end. And we're in Europe, I probably pronounced that wrong. I don't know. So the ORM here. The way you work with the database is you create query objects. And then you specify the type of the object that you're working with. And then you execute an operation on it, right? And the great part about Dart here is async await. Like, I'll be honest, that was like the deciding factor for all of this stuff. Having callbacks is not exactly fun for me. So this would, in this particular case, fetch every article from a database. So there's a corresponding article table somewhere, and it's got columns, and we're pulling in instances, every single one in this case, we're pulling in instances of those articles, right? The great part about this is the things that represent database rows in our Aqueduct applications, we don't have to do anything special to serialize or encode them, as I was saying a little bit earlier. I can pass them as the body argument to a response, and it knows how to serialize them, and then the HTTP controller will actually make the decision about the encoding, so JSON, for example. Now, you typically don't want to fetch an entire table. I don't think that happens all that often. Typically want to have some sort of where clause. And so this is the thing I'm most excited about. The idea is this. When you create a query object, there's a property called match on. I was trying to make this sound like a sentence, like match on the category where equal to. It only really reads like a sentence if you were born in a household that spoke SQL. Not my household. But the idea is this. Match on has the same properties. It's an interface to the same type that you're querying, right? Now, there's some special behavior that goes on underneath the hood to make this kind of all work, right? But the idea is that now we get the analyzer and code completion to help us build our queries. We don't really have to think about what I name this, and especially for refactoring. If you refactor and rename something, and you have stringly typed data, you end up in a pretty crappy situation. This allows us to build queries in a way that's very similar to the way that we do Dart tests, right? Dart tests, we use the Hamcrest matcher style. And so we have the same concept of matchers that we can apply to each one of these properties. So what we're saying here is, hey, I want to go fetch some articles, but I only want the articles that have a category that's equal to whatever I got passed in here. And I go and fetch them, I get the subset of articles, and I return them. Now, you can match on a number of properties. It logically ANDs them together. And there's also a number of matchers. And the matchers will be appropriately, you can pass in a date time, a number, a string. The underlying mechanism that takes care of this is going to tell you when you screwed up. Unfortunately, I can't do that at compile time, but the idea is that you can build most queries out of this. And there's a manhole as well, right? If you can't build the query that you want to build, you can drop down and just write the where clause by itself, or you could drop down and just write SQL by itself. So it's not preventing you from getting deeper, but the idea is it's there to do the things that you want to do in a much more productive way. With queries, you can insert, update, delete, fetch, all those sorts of things. So this would be an example of me wanting to update one of these articles, right? So when I'm building a query for update, not only do I still get my match on, and that's the thing that's going to specify which row I'm going to update or number of rows that I'm going to update, there's also a values object that a query has. And again, it has the same properties that this article object has. And so that's going to allow me to configure that thing. The great part about that, of course, is that the article object, or any of these objects that we use to represent database rows, they have this read map method, and that's going to bring in from the request body that's been decoded for you. It's going to bring in those values, and it's going to validate them. It's going to validate keys. So you send a key that's not appropriate, it'll throw 400 for you. It's going to validate the types of those values. Just kind of make sure you have the right data. Now, one thing you'll probably notice is that I've really not done any error handling, and for that reason, you might think I'm full of crap. But the idea is when a query has a failure. So first of all, if this fails, if there's a reason for this not to validate, we're going to get bumped out. We're going to get a 400 responded to, right? With queries, there's plenty of things that can go on. I could not get a connection to the database. I could have written a really weird query that doesn't work. The user could have gave me something weird. Could have a unique constraint violation. All those things are baked into the request control. Well, they're not really baked. They're decoupled enough, right? But when a query runs into one of those situations, it throws an exception. And the request controller knows how to interpret that exception. And so if this article, let's say that, for whatever reason, update date is unique, and that update date is already in the database for another row, I'm going to get a unique constraint violation exception from when I execute this query. The request controller layer is going to look at that and say, that's a 409, and it's going to respond with 409 to the requesting client. In order to get all that lovely behavior about being able to model a database in your Dart application, it's really a two-component thing. The first is something we call a persistent type. And the persistent type is going to be a plain Dart class. And that plain Dart class is going to have all the columns that are on that table. And the name of that table is going to be the name of this class. And there's a number of things you can set up: indexing and nullability and et cetera, et cetera. To get all the fun behavior that I've discussed, there's this concept of a managed object. If you're coming from iOS, you've seen a managed object before, because I ripped off the entire core data stack to do this. It's a really good stack. And so the idea is that we kind of wrap this thing in a managed object. And I'm not going to get into the specific details of how that works, but that's the thing responsible for translating between a database and serializing and deserializing data. We can also set up relationships. So if I have two objects, one that contains the other, this author, for example, has a managed set of articles. Managed set is, again, it's just like a set, except for it's managed like a managed object is. On the other side of that, I have to set up an inverse relationship. So what's going to happen here is in this persistent type, this resolves to rows in a database, and this, on the other side of the relationship, resolves to a foreign key column. And it will use the idiomatic naming conventions of the underlying database. So this actually ends up being author underscore ID, because the primary key of this guy's ID. When I have a relationship set up, I can fetch an object and its sub-objects, so I can do a join. And that's really great because I use the match on property again, and I say, hey, I want to include these. By default, you're not going to grab an entire object tree, right? So you can choose to opt into that. When you do opt into it, you can additionally specify extra constraints in the where clause. So I can say, listen, I want this author's articles, I want the author himself, and then I want the articles, but I only want the articles that are written about rocks. Another great thing, database migrations. So clearly, as you build an application, you've already defined your data model in your application by defining all these things. I ripped this off from .NET. Let me just clarify, I'm not that smart. I just ripped all this stuff off, but it's in Dart, so it's better. So the great thing about this is you get a migration file, you have a number of migration files over time, and you can execute those migration files. The other great thing about that, I'm not even going to get into this because you don't need to worry about it. Oh, son of a... All right, there we go. Because Aqueduct will actually do this for you. It'll generate your migration files by reflecting on your data model. And so when you make a change, you're going to get that change in a migration file. There's things that you can't 100% resolve. What is a rename? Is it a delete and an add, or is it a rename? So it gives you an opportunity to go in and modify those files. Once you modify them, you run validate, and it'll tell you every single thing that you did wrong. And once you're cool with it, you run upgrade, and that's actually going to run those actions in a transaction against that database. Okay, I have 3 minutes, so I'm going to go real fast. Testing, code that isn't tested doesn't work. Just one of those things. We try to have an ability to put things in a test harness that makes sense. When you use the template to create a new project, this code's all written for you, but there's no mocking, okay? The idea is this, I don't trust mocks, because it's more code that I wrote, and it's probably wrong. So it actually starts a web server, it connects to a database, it creates temporary versions of your tables. Those only exist for as long as the connection is alive, and then you can run your tests. We don't really care about this, because again, that's lower level. Once you have that thing running, by the way, this takes milliseconds, your tests are just, hey, I want to go make an authenticated request for this endpoint. It's a GET, and when I get it back, there's some additional matchers to complement the test framework that already exists to match against the responses. So here you're saying, listen, it needs to be a 200, and this is going to match the body. The body gets decoded according to its content type, and then you can specify a map or list and all kinds of matchers to ensure that the object that you got back is accurate. Make sense? And there's a word again. I like it. Accoutrement. Big thing, it's a very well-documented framework, because if it's not well-documented, you're not going to use it. Documentation's up on Pub. Thank you for doing that, or Dart Docs. The whole API is sort of named consistently, so the idea should be that if you're dealing with queries, if you type in query, you're going to find all the things that are related to queries, right? Don't want to make any surprises. Classes need to be clean. There's manholes, as I was talking about before. You can use bits and pieces of this thing. You can just use the ORM. You can just use the request controller stuff. You could use bits and pieces of the authentication mechanism if you want to. Customizable. Comes with JSON and form URL encoded, because I have to support the OAuth spec. So if you want to add protobufs or XML or anything like that, these top-level objects, or these classes, excuse me, the static methods, you can add closures that are responsible for serializing and deserializing data, or encoding and decoding, the different things. Greatest part, though, I feel like, especially when we're working on a big team, is it automatically generates an open API specification from your code. There's things that you can do to improve it. Thank you, somebody appreciates that. There's things you can do to improve and add more information to that. But just by default, you're going to get a lot of information by just running the one script to get all of this. And that's great. Put in your build tools, goes out to your entire team, and no one gets to say, well, when did you change this field? More information is available on our website. These slides, kind of, are up on SlideShare. I changed all of them last night. But the gist is there, right? And that's it for me.